Hi, today we are going to look at a Leetcode problem, which is a medium level problem, product of array except itself. So first, let's go through the problem statement and try to understand what it asks for. So you are given an array of numbers, integers basically, and we have to return an array answer such that answer I should be equal to the product of all the elements in the nums except nums I. The product of any prefix or suffix of nums is generated to fit in a 32-bit integer. Okay, so what it actually tries to say, let's go through this sample input. We have an array given as 1. We have this array 1, 2, 3, 4. So first I need to find the product of the entire array except this number 1, so which is equal to 2 into 3 into 4, which is basically 6 into 4, this is 24. So this number should be 24. The answer for this position is 24. The answer for this position is basically 1 into 3 into 4. That is the product of the entire array except this position I. That's what we are trying to find over here. So this one is basically 12, and this for this 3 we have to find the product of the entire array except 3, that is 1 into 2 into 4, which is equal to 8. For 4 it's the product of the entire array except 4, so basically that is 1 into 2 into 3, so that's 6. Yeah, and we have to find this array and return it as my output. You can see it's the same 24, 12, 8, 6. So we'll try to solve this problem. Basically what the problem says is that we have an array like this. Let's suppose this is my array, and I'm trying to find the answer for this position I. Then what will be my answer? The answer is the product of the entire array, that is a0 into a1 and so on till ai minus 1, that is till this position is I plus 1 into, we are ignoring ai, that is except this ith position we have to find the entire product, that is ai plus 1 and so on till a n minus 1. This one is n minus 1, this one is 0. So you can see we have taken all the elements except this element ai. So let me give you the intuition behind the solution of this problem first. You can see that I need to multiply from a0 till ai minus 1, and I need to multiply from ai plus 1 to an minus 1. So somehow if I could know what is the product of the array till ai minus 1, and somehow if I could know what is the product of the array from ai plus 1 till an minus 1, then my problem could be solved actually. So to get this, we'll use the prefix method, prefix and suffix method. I'll make a prefix array. Let's name this array as prefix product array, where prefix product prefix, let's call it prefix, and I'll define my prefix array in such a way that prefix of I will be equal to the product a0 into a1 till dot 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 till ai minus 1, sorry, till ai. That's how I'm going to define prefix array. And I'm going to define one more array which I will call as the suffix array. And suffix of I will be equal to ai plus 1 multiplied by ai plus 2 till an minus 1. So basically what this prefix array stores, prefix of I till this position is basically the multiplication of all the elements till here. I'm going to store that in my prefix array. This entire multiplication will be stored in this position. What will be stored in this position? I plus 1. The multiplication of the entire array till here. What will be stored in prefix of, let's say, prefix of n minus 1? That will store the multiplication of the entire array. Okay, so to find the prefix, what we need to do is I'll just calculate the prefix array using this method. We can say that prefix of I is basically equal to prefix of I minus 1 multiplied by prefix multiplied by a of I, because this thing is basically a0 multiplied by till ai minus 1, and I am multiplying this thing to this thing, so that's into ai, and this entire thing is basically prefix I. Similarly, we can say that suffix I will be equal to suffix I plus 1 multiplied by ai. So what is suffix I plus 1? By definition, suffix I plus 1 is basically ai plus 1 multiplied by ai plus 2 till an minus 1. That is, this thing is basically, if I'm at position I, this is I plus 1, this is I, so this entire multiplication is what we call as suffix I plus 1. That is ai plus 1 till n minus 1. This one is n minus 1. So, and we are multiplying ai into this, so it's ai multiplied by this entire thing, and what's that? That's nothing but suffix I as per our definition. Suffix I is basically the product of all the elements starting from I till n minus 1. That is, suffix I will store this value, and what's that value? Let's check it out. ai into a plus 1, so on until a n minus 1. This value will be stored in suffix I. Now I can construct this prefix I and the suffix I in order n time and order n space. And once I know what is my prefix I, what is my suffix I, what will be the answer for the ith position? Let's check it out. For ith position, my answer is a0 till ai minus 1 multiplied by something ai plus 1 till an minus 1. So this is nothing but prefix I minus 1 into suffix I plus 1. This is going to be my answer. So we just need to calculate our prefix and suffix array. And for every index I need to calculate this product, that is prefix I minus 1 and suffix I plus 1. Let's try to understand the code. So prefix I is equal to prefix I minus 1 multiplied by A of I. So that's how I'm going to calculate. And okay, so I need to run a for loop from I equal to 0 till I less than n I plus plus. What I'm going to do is prefix I equal to prefix. Let's run this loop from I equal to 1. Prefix I equal to prefix I minus 1 multiplied by ai, and this prefix 0 is equal to basically a0. Similarly, we're going to do it for the suffix array, and the suffix n minus 1 should be defined as a of n minus 1, and I'll start the loop from I equal to n minus 2, run till 0, that is I'm coming in this direction, calculating for each I values. So basically suffix I was equal to suffix I plus 1 multiplied by ai. Now once we have calculated the prefix array and the suffix array, we need to calculate the answer for each. 0, I less than n. I'm going to calculate the answer for each of these I. I'll define something called as prefix product that is equal to 1, and I'll define something called as suffix product, which is basically nothing but the product of I plus 1 till n minus 1. Prefix product will contain the product till 0 to I minus 1. And let's say that if I minus 1 is greater equals 0, then prefix product equal to prefix I minus 1. That's the product from 0 to A. That's it. And I'm using this just to handle the edge cases basically, that if I'm at index 0, then prefix of -1, this is going to be -1. If I equal to 0, then this is going to be -1. So that doesn't make any sense. So in that case, this condition is going to be false, that is -1 is greater than equals to 0, I minus 1, that is 0 minus 1, -1 greater than equals to 0, this condition will be false, and I want to be coming here, so I won't get an error, and my prefix product will be 1, which I have defined over here. So multiplying 1 with my product doesn't make any change, so that's kind of a edge case handling tactics, you can say. And I plus 1, if this I plus 1 is less than n, then suffix product equal to suffix I plus 1. And now what is my answer? Answer I is equal to prefix product multiplied by suffix product. Yeah, and that's how I'm going to calculate my answer. That's for this one.